Hi and Assalamualaikum. Today, this video will be talking about titration between strong acid, SA, and strong base. So for strong acid, I will be using hydrochloric acid, HCl, for the example, and then for strong base, I will use sodium hydroxide. Okay, so we look at the equation first. So this is actually a titration equation between strong acid and strong base. So strong acid, as we know, hydrochloric acid will dissociate completely to produce H plus and also Cl minus. For sodium hydroxide, will dissociate completely to produce sodium ion and chloride. Sorry, this is actually OH. I will correct it. OH. Okay. So now sodium hydroxide, and then when both of them titrate or mix with each other, it will produce water and sodium chloride, salt. This is neutral salt, and then this is water. So neutral salt, Na plus Cl minus to produce sodium chloride, and water is H plus OH minus to produce H2O. This comes from this part. The component here, the ions, it comes from both acid and base. Okay, so let's say we are doing a titration. Our HCl is the analyte, our sodium hydroxide is the titrant. So what is actually analyte and titrant? So analyte is the one that is in the conical flask. The titrant is from the burette. Okay, so when you titrate this, the titration process will occur, and then we will measure the pH. After we measure the pH, you will get this type of graph. Okay, so now I want to discuss to you what actually, how do we actually calculate the pH for a titration. Okay, so let's start. Let's look at this curve. So I can actually divide this curve into three parts: part A, part B, part C. Part A is before equivalent point, B is during the equivalent point, C is after the equivalent point. There will be, you can say there are three different calculation, three different types of calculation. Okay, this is based on what ion exists in the conical flask. It will depend to this one. Okay, so let's look at first part A. So part A, we focus on the first point here, that is before titration start. So before titration start, we know that the analyte contain hydrochloric acid, HCl. So in the conical flask, you will have H plus and Cl minus. Okay, so what is the concentration of H plus? Because hydrochloric acid is completely dissociate. So you know that if it is 1 molar hydrochloric acid, so the H plus is also 1 molar. So this is 1 molar here. So how to calculate the pH before titration? Here at this point here. So it is just plug in the concentration of H plus into the formula. You will get the pH before the titration. That is easy. Okay. Okay. Next, we we add in drop by drop of sodium hydroxide, NaOH. So when you add in drop by drop, so what will happen in this conical flask is NaOH will be added into the conical flask. The problem here is you need to determine what ion exists in this conical flask after the addition of sodium hydroxide. So first, at the beginning, you have hydrogen ion and also chloride ion. After you add in sodium hydroxide, what ion will exist? You will have Na plus and also OH minus. But at the beginning of the titration, the amount of OH minus will be neutralized completely by H plus. Okay, so for example, this is 1 mole of H plus. After that, you add in 0.1 mole of NaOH. So what happened? You will have Na plus and Cl minus. Both of them are spectator ion. They will not involve in the pH or in the reaction to determine the pH. So what happened to OH minus? What 0.1 mole of OH minus? So I write it down here. So what you will get is 0.1 mole of OH minus. So which of the following between H plus and also OH minus, which of the following will have higher number of mole? So you will see that H plus will have higher number of mole, or H minus will be completely neutralized. So I will cancel this because it will completely neutralize. So how many mole left for H plus? It will become 0.9. Okay, so that is the amount of mole of mole of H plus. Now you need to get the concentration for H plus. So from here it is 1 liter, but you need to add the amount of sodium hydroxide that you add in. So for example, you add to get this 0.1 mole, you add 100 ml. So here you need to divide it with 1.1 liter, and then the concentration here you will calculate it into the formula. So you will get the concentration, the pH at certain point. So you can say that at region A, at part A, the dominant species will be H plus, and also others ion that exist will be Na plus and also Cl minus, but both of them are spectator ion, or will form neutral salt, which doesn't involve in the determination of the pH. Okay, so that is what will happen at part A before the equivalent point. Okay, now we will look at what happened in part B. Part B is when the equivalent point, where the equivalent point exists. So what happened actually at equivalent point? Yes, the amount of H plus and OH minus is equal. So if it is equal, so means that 1 mole of H plus will be completely used up to neutralize 1 mole of OH minus. So I can put here the total amount added is 1 mole already. So if it is 1 mole, so it will completely neutralize each other. So what will left at the end will be Na plus and Cl minus. Where does H plus and OH gone? It will form water. I forgot to include water in this equation. H2O will exist there. So B, what will exist? What is the dominant species here now? It is H2O, Na plus and also Cl minus. So what you can conclude from here is both of them will form neutral salt. So water, as we know, the dissociation of water, you have Kw H plus or H minus, because both amount is equal, so you just square root the value, so you will get pH 7. So the equivalent point here will be pH 7. So the dominant species here is H2O. You minus both of this, it will gone, hilang. Okay, so that is for part B. Okay, so if we look at this formula here, M1V1 equals to M2V2, this is the amount, let's say, how much volume of NaOH I need to add that into HCl so that it will we will have pH 7. So means that how much of NaOH to have the neutralization to be completely neutralized. You need to neutralize all of this. So how much do you need to add in? So you can use this formula. M1V1 is for acid and then M2V2 is for base. You know the concentration of acid, 1 molar, volume is 1 liter. The concentration of sodium hydroxide is 1 molar. So what is the volume needed? It will be also 1 liter. So after 1 liter of OH minus sodium hydroxide you add into the conical flask, then you will achieve the complete neutralization. So it will be pH 7 here. So you can see that the curve is very vertical because at this point the amount of H plus is already missing, and then it is this vertical point means that the pH change drastically because there is no more H plus ion. Okay, so this is where the dominant species will be H2O and both of sodium ion and chloride ion. Okay, after that, at region C, what happened here is because of OH minus is completely neutralized, there will be no more OH plus, but the additional drops of sodium hydroxide will contribute to the increased concentration of OH minus. The OH minus will increase starting from here until the end. So you can write it here. The dominant species now will be OH minus. Both of the neutral spectator ion just now form neutral salt and also water. So to determine the pH at part A, you will use H plus. Use the formula here. Here. And then for part P, you will use the ionic product of water. It is equal to pH 7 here. And then for part C, the subsequent addition of sodium hydroxide will cause the pH to be basic. Why is that? Because there is no more H plus. OH minus is in excess. So you use OH minus. How to calculate the pH over this region C? You just negative log OH minus, you will get POH, and then 14 minus POH, you get pH. Or you can use KW to find out what is the H plus concentration. Insert the OH, and then you get H plus. Like always, seperti biasa, you just negative log H plus. So that is for strong acid and strong base titration. Okay, and then for the indicator, we will choose indicator along this vertical region. Okay, along this vertical region, the color change must be along this region also. We will choose indicator which is the color change close as the equivalent point if possible, and then must be at this vertical line. If you choose the indicator at this line, at this region here, it is not suitable because it is already basic. You didn't actually show where the pH change. Okay, so that's all for the first video. It is about titration between strong acid and strong base. Thank you.